An expression itself is just a string of variables, letters, and numbers. Okay, we'll talk more specifically about types of expressions, but when you look at an expression, you need to be able to identify a couple things. First of all, the terms. The terms of an expression are just the parts of the expression that are separated by an addition symbol. Okay, now, if you think about subtraction is equivalent to adding the opposite, there are unwritten plus signs in front of each of these negatives, right? So it's kind of like saying plus a negative 21x squared, plus a negative x. And so if you think about those, it allows you to identify and separate the terms of each expression. So when I look at this, the terms of this expression are all of these values that are separated by the pluses. So a negative sign carries along with the term. Okay, so when I ask you to list the terms of an expression, so negative 5x to the fourth is your first term, then 3x cubed is your second term, then negative 21x squared is your third term, then negative x is your fourth term, and then 3 is your final term. Okay, so when you identify terms, you keep them all together. The sign carries with it, and it's just everything that's separated by the plus symbol. Now, don't get that confused with the parts of a term. So in each individual term, you have a coefficient, which is the numerical multiplier. In each individual term, you may have a variable, which is the letter that represents some unknown quantity. And then if you get to a term that has only the coefficient part to it, where there is no variable associated with it, you might also see that called a constant. Okay, now with respect to the terms, you might have to be asked to identify the degree of a term. Okay, so the degree of a term is the power, or the sum of powers, for an individual term's variables. All right, so when you look at each individual term, those terms could be identified by their degree, and the degree is just the power or the sum of powers of their variables. So when we look at this first term, what is the power or sum of powers of its variables? 4. So this is a fourth degree term. Okay, what about this one? The highest power of the power is 3, so it's a third degree term. And so on. Here's a 2, so second degree. Here's an unwritten 1, so it's a first degree term. And a constant is a 0 degree term. Okay. Now, in addition to this, you might see that an individual term has multiple variables. So if I gave you something like the following. Okay, so here's a couple terms that have multiple variables. For them, the degree for each term is going to be the sum of their variable powers. Okay, so here we have a 4 and a 2. They add together to give you 6. So this is a 6th degree term. And then here we have an unwritten 1 and a 3, so this has a degree of 4. All right, the final thing is the degree of a polynomial. Okay, so in these two examples up here are what are called polynomials. We'll talk about that in more detail later. But a polynomial just has non-negative or basically the powers of the variables have to be whole numbers, and that's in order for it to be a polynomial. And the degree of a polynomial is just going to be the highest degree term of the whole expression. And so if I looked at this whole expression, it would be a fourth degree polynomial, because the highest degree term in it is 4. Okay, what would this one be? Sixth. Whatever the highest degree term is, so this would be a 6th degree polynomial. Okay, so that's talking about the whole expression, or the expression as a whole, versus the individual terms.